Hi, I'm an old guy and I do maths, and today we have an interesting problem. Let's have a look at this circle. Now we're told that if angle CAB is 1/5 the size of angle BCA, and that chord, it's called a chord, BC, this line here, is 17 centimeters, we should be able to calculate the area of the circle because we've been asked to. Right, so let's get to work. Now, we have a couple of things going for us. We know that this angle plus this angle must equal 90 degrees because that is a right angle. So, what we know is that BCA is equal to 5 times CAB. So 5 CAB plus CAB equals 90 degrees. So 6 lots of CAB, this angle here, must equal 90 degrees. So 90 divided by 6 will give us 15 degrees. That thing there is 15 degrees. Now, what that's going to do in terms of our finding the area of the circle is it's going to allow us to find the length of this diameter, and from this diameter we can find the radius, and from that radius we can find the area of the circle. So let's get to work. Let's just draw this triangle in a way in which it will be helpful to us. So that is A, and that is 15 degrees up there, in there. This is 17 centimeters here, so I'll just note that, 17 centimeters there. And we are looking for this, the line from A to C, the hypotenuse of this triangle. Now, what that means is that we have an angle, we have the opposite side, and we're looking for the hypotenuse. So that's going to involve a sine, and the sine of 15 degrees is going to equal 17 over x. So if we rewrite that, x is equal to 17 divided by the sine of 15 degrees. Now, my calculator is missing in action. Well, my good calculator is missing in action, and so I've decided to get out my tables. These are the tables that I used in school. This is not the edition that I used in school. That's long turned to dust. But in here we have sines, sine values. And if we look for 15 degrees, it is, where are we? Just there. 2588. Okay. So, let's do it the old-fashioned way. So, x is going to equal 17 divided by 0.2588. Now, I do have a calculator here, but it's this one. No sines, cosines, or tangents on that. So 17 divided by 0.2588 gives me 65.69 centimeters. Okay, so we know that this line here is 65.69 centimeters. So we can find the radius. We simply divide that by 2, and the radius is 32.84 centimeters. There's the long decimal. Okay, what are we looking for? We're looking for the area of the circle. It's going to be pi r squared. So pi r squared, pi times 32.84 squared. Let's go to work. 32.84 times 32.84 equals 1078.4656. There we are. Now, this calculator doesn't have pi on it, so I'm going to use pi as 3.14. Okay, you'll often see that in tests and things like that, where you've got minimum access to calculators or no access. So pi times this times 3.14 gives us an area of 3,386.38 centimeters squared. That is our answer. That is how you get it. And you can even do this using equipment from the Dark Ages like I just did. So let's just go over this. The first thing that we really need to take note of is what it is we're looking for, the area of a circle. For that, we're going to need a radius. How do we find a radius? Well, we're given some information about this triangle in here. And we can use the information that we're given to work out this angle. We know that length. Then we're just into straight trigonometry, very simple trigonometry using a sine ratio. And we are looking for this length. I know, given the way that this looks, you could be seduced into thinking that you're looking for that length. You're not. You're looking for this length, the hypotenuse, because that's where the right angle is there. Opposite over hypotenuse gives us the sine of this. We can use that to find this length. Half of that length is the radius that we need. That's there. Once we have that, it's a very simple calculation. Pi times the radius squared. We'll assume, for the sake of this video, that pi is equal to 3.14 because my calculator can't stand anything more complicated than that. And therefore the area that we get is 3,386.38 centimeters squared. That's the area of that circle. I hope you found this interesting and a useful approach to problems. If you did, please like and subscribe, and I'll see you next time. Bye.